Good evening, everyone. Welcome to the Chicago booth Big Data and Analytics Roundtable. I want to let you know that this group, this roundtable is all about you. We put together programs, material that should be interesting to Chicago booth alumni. So a little bit more of a business focus, but I would imagine to say that most of us that are here aren't terribly afraid of technology either. So technology savvy and business focused people, I look for you to help me out too. Please, as a part of this group, let me know that, if you have somebody that could be a good speaker or even a topic. If you got an idea for a topic, please let me know. And then spread the word, get out and let people know that this thing exists. Get them to sign up either for the meetup group or there's a mailing list on the U Chicago alumni site. And then also you're more than welcome to volunteer and be part of the team. We have, basically three sets of committees that we use. Program committee is responsible for identifying and lining up our speakers. Marketing committee that gets the word out to everybody about this, that it's going on. And then logistics committee, which has been very quiet because our logistics is basically just meetup right now. If and when we get back to in person, we'll be looking to kind of staff up logistics again as well. And they help check in people and make sure everybody gets to the right place, that everybody's getting their drink tickets, because we tend to be, well, it's nice to be at, Bleacher Center and Wolfgang Puck with a nice bar set up and some appetizers. So I'm looking forward to getting back to that. Not more so for the people, but certainly the drinks don't hurt either. For the evening, the schedule is basically, I'm taking up this first few minutes just telling you about the group. I will talk about the, kind of a couple of announcements, basically. I want to tap into this group to see, are there jobs out there? Because if there are jobs related to data science, to AI, to analytics, there's potential that there are people online that would be interested in those. So I typically have people that have a job posting, let us know and describe it, and then pop something in the chat so that other people can grab that and reach out to you or look at your job board, whatever it is. And then also check in and see if there's other events going on that would be of interest to people in this group. And that kind of gets us going, okay? On the sites, I think I've laid it out. The only thing I'll call out, we do record these. This is being recorded, and we have a YouTube channel that we put these up on. I try to get these out within a couple of days onto the YouTube channel so you can see them. There's, I think, 4 or 5 out there. All of the Zoom meetings that we've done, I've put out there on our YouTube channel. I am working with the university to go into our kind of old stuff that was done at the university, at the Bleacher Center, and get those out on the YouTube channel as well. They're a little bit easier to watch there, I think, to get to and to watch. I found out that they had a major crash on their media system, and they did lose a stack of our videos. At least that's what I'm told. I'm trying to find out what we've got left. We'll find out, but I'll, again, try to get those. So if you want to go back and look at some of the interesting things that we've done, and speaking of that, let me, pop, this is, we've done over 50 of these over the past about 5 years. And lots of interesting things that we have that we can talk about, that you can take a look at and see if it's of interest to you. In fact, we have one of the speakers here with us, Rebecca Pop, spoke a couple of months ago, and turning data into storytelling was what she did for us. In fact, I've asked her and she's agreed to pick up one of the breakout rooms after the presentation. So if you want to talk to Rebecca about data storytelling, or if you want to talk to Meki about the AI presentation that she just completed, you'll be able to do that. And I'll stay in the main room and answer questions about the group or anything else that we want. And if anybody else needs another breakout room, I can set it up and allow people to pop into that as well. Okay. Any questions about the group so far? Okay, so again, the two things I want to ask is, anybody out there got a job rec they need filled that this group might be kind of key to filling?
Hi, Roger. This is Lance. I'm actually hiring a data scientist. I've posted the link to the role, the hiring manager. So take a look and let me know if anybody's interested. I also I'm providing visa sponsorship for anybody who's on OPT.
Oh, I'm sorry, say it again. Providing, business sponsorship. Okay.
Yes.
All right. Very good. Thank you, Lance. I appreciate that.
No problem.
Anybody else? Aaliyah, I know you have something. I saw it up on Facebook.
Yeah, my former employer, West Monroe Partners, is looking for a full-time contractor position to fill for 6 to 8 weeks. It's a dev role, so they're looking for a developer that would be doing some data analytics using Tableau, building new reports, as well as their I think SSAS, so data modeling using Cube Analytics. So I can also post something in the chat in case anyone's interested.
Yeah, aren't you happy to see that I cold call even?
Absolutely, yeah.
You should be used to it. And for everybody else, Aaliyah was a student of mine at University of Chicago in the Master of Science and Analytics program. So we've got a couple of those floating around too. So that's good. All right, any other job postings? All right, so there's a couple of those. The second thing I like to ask is, do you know of anything going on, any events, any meetups, anything that this group might be interested in attending?
Yeah, I'll post the link. I have an upcoming 1-hour workshop on data visualization. It's called six advanced graphs you should use. Basically walking the participants through examples of 6 more advanced graphs beyond the line chart and the pie chart and the bar chart and all those. Okay,
very good. Thank you, Rebecca. And if you missed the data storytelling, you can go watch the video and then see the 6 charts too. So that should be good. Okay. Anybody else with anything that's going on?
Well, there's the Data Yap conference that's going to be coming up next month.
Yes, there you go.
And you're going to be there, and Rebecca's going to be there. So a bunch of great people are going to be there presenting.
And do you have information about that? Can you maybe put that in the chat? The
I
link?
will, yes.
Oh, that'd be great. I'd appreciate that. All right, anything else? All right, so now we've got the silly stuff out of the way, and we can focus on the important thing, which is the presentation. Mecky, I apologize for this, but I just find that speakers can do a much better job of telling those attending about themselves than I can. So I'm just going to kind of hand it over to you, and you can start your presentation on AI. I appreciate your joining the group. So Mecky, it's all yours, and I'll stop sharing and let you get started.
All right, let me get this sorted. Can anyone see my screen yet? No?
Not yet.
Okay, get this going.
Don't you just love technology? We literally tried this before, so
I think it's coming. It's just taking a bit of a time. It's taking
Okay.
sweet time. All
Okay.
right, let's see here. All right. All right, here we are. So hello everyone, and welcome to this session of Big Data Roundtable. I am very excited to be here. My name is Dr. Mechi Kengla, and I am the founder and principal chief data strategist at Data Products. We are a data science consulting firm. So
Okay.
my background is I'm primarily a mathematician, and so I think in terms of numbers, but my guiding light has been data all through my many, many decades of career that has spanned academia, research and development, government, startups, and Fortune 500s. So I am very happy to be here and to present to you about driving business value with AI technologies, and I hope you find some value in this as well.
Okay. I am still not seeing your screen.
Oh, you're not? Oh.
Nope.
Huh. All right, okay. Let's see here. All right. It's interesting.
There we go.
Okay. Does that work?
That works. There we go.
Fantastic. All right, so let's get started. So today we're going to be talking a bit about driving business value with AI technologies. Next slide. Our focus is going to be on we're going to talk a bit about what is AI. We're going to talk about base and core AI functions, everyday AI usage, principal AI business values, use cases of AI technologies in enterprise business, challenges that are faced by enterprises in actually implementing and driving value, the barriers to success, right, that are caused by these challenges, and a practical, simple guide to drive AI within your organization. And we're going to wrap it up by tying it up with our key message, which is about the value of AI within the business. I would like to say that this is meant to be more engaging, so please feel free to interrupt and ask questions so that it can be more lively and enjoyable for everyone. So what is AI? I'll start by telling you a little bit of backstory, a very brief backstory about what AI is. So the term artificial intelligence really was coined by John McCarthy. He was a professor of computer science at Stanford University. He had organized a conference in 1956 where researchers focusing on a wide range of topics, right, from language simulation, neural nets, complexity theory, and other topics, were all invited to discuss this new subject, artificial intelligence. During the conference, they worked to develop ideas around thinking machines. And now you fast forward all the way to today, where we tend to focus on AI as a subfield of computer science. So the focus is on AI is really about how machines can imitate human intelligence in a variety of ways, right? The goal is to develop computer systems that can complete tasks such as make decisions, perceive objects visually, speech recognition, and tasks really that requires, like you guessed it, human intelligence. So what we say AI is really a subsection of computer science that focus on the study of having computers imitate human intelligence. Now, for our purposes today, we are going to look, when we talk about AI, we're going to talk the broader sense of AI technologies, right? And this will include other technologies like 5G, robotics, autonomous machines and vehicles, drones, UAVs, NLP, linked knowledge graphs, machine learning, Internet of Things, 3D printing, augmented reality. You get the gist. And the reason why it's important we talk in the context of all these technologies is because AI really converges in all of them. Whether it's the data that feeds it, that drives the technology, or the action that's driven from the technology, it's all boiled down or interconnected with AI. So for our purposes today, as we're talking about AI technologies, each and every one of these will be included in some aspect in that conversation. Okay. So generally, when we talk about the core principal functionality of AI, we're usually targeting one of these four main criteria, right? Usually we use it in terms of prediction, right? Optimization, discovery, or detection. And these are the core functions. We can build upon it to build a solution around things. But at the very basic level, AI is doing one of these things. Is it predicting, optimizing, discovery, or detecting? Let's take an example, right? So now in our everyday lives, how do we use AI? And how does it tie in with these four core functionalities that I laid out before? So if we look at prediction, right? How do we use it, right? You have your purchase preferences when you go online. You have recommender systems telling you, I recommend you to purchase this product. You have credit scoring that tells you, I can predict what your score is going to be. They predict, your smartphone tells you autocomplete when you're typing a text by predicting what sort of a message you're trying to send. Those are common examples to take, for example, but that's all AI acting in a sort of predictive manner. For optimization, we think about our schedules. There are scheduling that are optimized to fit a certain goal. We have traffic routing. We all use Google Maps sometimes to direct us the fastest means to get to our destination. We have personalized learnings that say, well, for you, based on what I've seen in terms of how you've chosen to learn before, this is a sort of mapping I would recommend for you to choose to learn, right? It's all optimized and personalized for our specific use case. And we use this all the time, but it really doesn't occur that we're using AI. It really just means we're using some sort of technology. What about discovery? In discovery, we talk about health. We have health issues, right? We have wearables, all the smart watches, right? So it discovers what's going on with your body by collecting myriads of informations and data points. We have coupons being sent to us by the best deal, or the best bed and breakfast, or the restaurant that you like to visit. So it discovers what we are good at based on the pattern of data that we have exhibited in the past. Detection, we talk about social sentiment, right? How are we feeling based on the way we interact on social media, for example, right? Identity theft, it can detect if there's some theft, someone's pretending or someone's odd, an anomaly in the occurrence of what is being deemed as normalcy. Our credit card fraud, this has been used in a region or in a store that you're not used to going. So all of this tying and raise the flag, and it's AI being detected something that's going on. Now, what about AI business value, which is really the core of the presentation today? In today's world, when we talk about business value, AI business value, it really boils down to three main core business functions. We talk about customer experience, we talk about generating new revenue, and we talk about cost optimization. So regardless really of what we're doing in business or how we're leveraging AI, the majority of the time, 80% of the time, is going to fall into one of these three categories. So let's talk about some examples. Let's talk about some examples of how AI is used in enterprise data. So we're going to cover quite a few, a wide range of examples. And again, folks, please feel free to, whether you're sharing a comment or a thought or a question, very welcome. So let's talk about computer imagery and vision in manufacturing, right? There are quite a few examples, as you see I've listed out here. So for predictive maintenance, this really is what allows manufacturers to optimize the lifetime of the equipment and reduce performance costs, right? We have package inspection. How is computer vision used there? By inspecting the goods and quality control that are most important, right? For the manufacturing activities that should not be ignored, right? If you do that, then you save. For example, pharmaceutical companies have trouble counting capsules before they're packaged, before packing products into containers. This is a good example where you can have an AI system using computer image or vision solution scan the package and automatically count with very high accuracy the capsules that are in the package. Another example for computer image and vision, say, and that focuses on manufacturing, is say recognizing and reading barcodes, right? And text that's really not an easy thing to do each and every day in high volumes of containers and packagings of many different sizes. But this is something, again, that can be automated by using image or vision computer system, which is an underlying AI technology to do so and save time. With improving worker safety, this is a key one, right? By providing better health for workers and keeping a safe environment, which is a major concern for product manufacturers, right? Basically, you can leverage AI to do that, which means that it can recognize when an accident is about to occur, where someone's violating some sort of a safety measure, and preemptively give a warning so that they can be rectified, right? All of this helps in sort of mitigating the security or safety events that it should occur. This proves that, basically by doing this, proves that security measures and safety programs which are not adequate can certainly be elevated by leveraging these computer vision systems. What about natural language processing, which is another key sort of usage of AI? Let's focus in banking and finance, right? I've laid out some couple of examples here: automation, data enrichment, search, discovery, and cutting costs. Let's take automation to start. So NLP really can replace the manual processes that financial institutions employ to turn unstructured data into more usable form. For example, automating capture of earnings calls, management presentations, and acquisitions announcement. I'm sure most everyone here is from a business background, so you understand it. But the public at large, when they think of finance and banking in general, they think that the data is structured, right? They expect to see stock prices, so much structural tables and all numbers. This is patently not true. Majority of the data that occurs in finance is actually unstructured. So when you have any earnings call or reports, what you find is some sort of a text, right? An analyst writes a story and puts that number in. So it's more of an unstructured or semi-structured in certain cases that needs to be processed to get to that very structured stage, or to make some sort of actionable insight and get learnings from it. Now, moving on to the data enrichment, how does that work in finance or banking, right? So once unstructured data is captured, adding context to it makes it much more searchable and actionable. Machine learning can enrich that raw text with metadata by flagging sections that address, say, environmental impact, financial impact, or other topics of interest. So if I'm going through someone's loads and loads of financial data, I'm interested in just looking for the environmental impact of certain companies, I can have a system that does this automatically for me and then focus my attention on only reading those parts of the document. This, of course, ties into, I think skip there. This, of course, ties into search and discovery, right, which is the next big thing. So with search and discovery, finance really is on a mission to find competitive advantage in broader and more variety of data types. But what's missing is a search experience that's very effortless and very effortless and effective as a Google search. And what consumers are really accustomed to. So this, again, is an opportunity where natural language processing can be developed specifically for banking or finance use cases. Of course, not to forget cutting costs, right? That's always a big deal, cost optimization for most organizations. By having employees that manually review thousands of contracts annually, you're straining the bank's human resource systems and limiting potential growth, right? Additionally, when you have humans doing such menial work, the probability of human error is quite high. But if you have an NLP solution, right, that's developed, for example, to identify and categorize repeating clauses, this will save banking attorneys and resources. I've seen the case study was saved a company over 360,000 hours annually. If you can imagine that, 360,000 hours annually. That's quite a lot. And we're talking about billing rates for attorneys here. So the impacts could be quite significant.
Hi, this is Anand here. Can I add a point?
Sure.
Yeah, so just to add a comment, we are also seeing the usage of techniques like NLG in banks, which basically want to reduce the time to document a model validation report. Now, these are specific to every bank has a modeling department, and they have to always write tons and tons of document on what their model is and validate the models and submit reports to regulators.
Right.
So what we see is banks now increasingly start using NLG as a technology, wherein they automate the entire model validation report. This basically cuts down the time to write a document. I mean, I have seen banks which are typically using 3 months to actually write a voluminous model validation document to less than a week, wherein you document it, it's just proofread and then submit it to regulators. So that kind of aligns to your point of cutting costs and improving or increasing automation in the entire process. So just a point to add.
Right. No, that's a great idea. This example you gave there, absolutely. So there are so many different ways that it can be used in terms and with really high tangible impacts to the bottom line of the organization.
And I'll throw in, we've actually had narrative science present to this group a couple of times over the last 5 years. And they're a company that actually works on that, writing a story from structured data. And they specifically, I don't remember if they call it out specifically, but I was aware that they worked with Standard & Poor's, both in terms of analyzing these governmental reports. So the NLP to pull out the information that they needed people to see, and vice versa, being able to generate voluminous reports out that were actually very dry, very boring, something that most writers do not want to do. In fact, yeah, that was one of the things. It's like, we're taking jobs away from writers. No, not in that case. Writers would rather, in some cases, I think, commit suicide than have to write a 250-page report on financials. So there are things it does help, and it cuts costs, and it takes away jobs that just people don't want to do.
Yes, great points, guys. Very good points. Keep them coming. So moving on to the other AI technologies, we talk about augmented reality, AR and VR. What is AR? really is a computer-generated image on the user's view of the world, right? Thus providing a composite view using multiple data sources. Examples of this can be used in retail, right? So you basically use AR to actually experience a retail experience, to have a retail experience for disaster response. So using AR, someone can see a scope what the disaster is. It's also used in terms for machine maintenance, back again to my manufacturing examples. So you can use AR to sort of get a composite visualization of what's going on in the machine and when it needs to be maintained and how often. For VR, VR examples of that really run to, so VR is, again, a computer-generated, data-driven simulation of a three-dimensional environment that can be interacted with in a seemingly real or physical way by a person that's using the electronic or the special electronic equipment, such as a helmet or a screen or goggles. So inside the equipment are usually fitted with sensors that collect data and data generators. So examples of VR would be games, right? That's the most common one that people have heard. We have family adventures that people experience, training and education where people simulate environments and they experience it, medical treatment and design, and big data exploration as well.
Hey, Meki, I just noticed that there was a question in the chat from Jiwa Wang, and it was from a few minutes ago. So I will ask Jiwa to unmute and ask the question and give context. Can you do that? Or I can read the question. Maybe you'll get it, Meki, but what's the biggest challenge when you transform a business problem into AI use case? Can you give an example?
So if you have a business problem, not the biggest challenge. It's I think in the implementation, right? Getting the buy-in. And I personally think, from my experience, is getting buy-in by showing the value. And I'll talk about that later on. So it's actually easy when you have a business problem and you can abstract it in terms of this is what you would like to see and sort of work to get a solution and implement it with AI technologies. The problem is, how do you go about, it's not just a one person using it, right? It's an organization at large. How do you get buy-in from your superiors? How do you show proof in terms of that there's tangible value that has a real effect on the bottom line? And how do you get engagement from the team and the rest of the organizations, other folks using it? Because there are lots of examples where organizations have developed AI solutions, but they've gone to die, right? 3 months, 6 months out, people start using them less and less and less, and all this effort and money that was pushed into it has gone to waste. I think it's true as well for big data and analytics solutions as well. So it's not just the developing of the solutions, also the rolling out and actually deploying and getting engagement.
Yeah, and I'll say it in just a little bit different way, but very close to what you were doing. When we, at Gartner, I work with a lot of clients where they're like, let's throw AI. In fact, that's usually what, just business people that don't understand technology are like, yeah, I hear that machine learning stuff does really cool stuff. Use that to solve this problem. And what you need to think about is, I've got a problem, and there's usually a full spectrum of things that you can do. Everything from a heuristic model, if you have very limited data, to more analytical solutions like regressions, all the way to potentially deep learning, but it implies an excessive amount of data that you have available to solve it. So there's a business problem, and then there's basically a spectrum of solutions ranging from simple to very complex. And there's cost and time associated with those and requirements, and you need to work it through. And the biggest thing is AI doesn't solve everything. AI might not be able to solve it because you don't have enough data. In fact, I can't tell you the number of times people are like, let's do this. And it's like, you don't have the data. You don't have enough information to go after this in that kind of approach. We have to back off. We have to start collecting the data now so you can do it in a year or so. But right now, you have to work at it a different way.
Well said. Okay, moving on.
And Hassan, just while you're catching up, Hassan sent out a note. The single biggest problem is understanding what type of neural network to use correctly in your case, your use case. So yeah.
So when we talk about robotics, right? Robotics is another extended AI technology. Really, robotics is not so different from AI. It's really a branch. I contend that's a branch of AI that's concerned with creating devices that move and react to sensory input. That's data from sensors, right? And examples from robotics, right, could be automated manufacturing assembly lines, the Roomba that cleans your house when we're too lazy to sweep, warehousing and logistics, prosthetics, right? And we even have dancing robots and that robots for fun. And maybe who knows, we might have robotic house helpers in the future. That would be so cool to do all the stuff that we as humans really do not care to do. But yes, really that's the extent of AI, of robotic AI. And those are some of the examples in terms of how it's used in our everyday life as well as in organizations. My robot came late. Drones, right? So we have drones as well. That's an extension of AI. So drones, these are unmanned aircraft, really a flying robot, to be frank. And really, it's either remotely controlled or flies autonomously through a software-controlled flight plan and onboard sensors using GPS, right? They are useful for search and rescue, for civic applications, say surveys, for disaster response, military operations, and fun, right? There's always the fun aspect of AI things as well that people don't call out as much. It's also known or labeled as a UAV, which is unmanned area vehicle, or UAB, which is a unmanned area, UAS, sorry, unmanned aerial systems. Those are other words as well for use for drones. Let's talk about 5G. So this is one of the more recent technology innovations that we've been hearing quite a bit for the last year or two. What is 5G? 5G is really just generation 5, right? So it's a fifth generation wireless system. It's the latest iteration of cellular technology. It's engineered to greatly increase the speed and responsiveness of wireless networks, right? 5G will also enable a sharp increase in the amount of data that's transmitted over wireless systems due to more available bandwidth. Think of it as a more intricate or a highway system with significantly more lanes, right? So it can allow a lot more movement of cars, which is the data, and you can get to your destination faster if you are the data. Examples would be of applications would be high definition and 3D videos, right? We have broadband network access nearly everywhere. We have internet speeds that would be ridiculous. Think gigabits per second sort of speed levels. That's quite a lot of speed and power, much more than where we are today with our 20 gigabytes or something of that nature. Another and very prominent application of 5G is going to be in IoT, right? Internet of Things. So I can go through a lot of these AI technologies, but we've covered quite a few. And just to round it up, we have autonomous vehicles, which are self-driving, again, guided without a human. cars that are informed by data streaming from many sensors, right? Cameras, laser, radar, and they make decisions and actions based on the data-fed algorithms within the software of the vehicles. And you have 3D printing, right, which leverages ML and AI computer vision models for people's traffics and stuff. So you have 3D printing, that is a process of making a physical object from a three-dimensional data-informed model, and typically does that by laying down many thin layers of material in successful cross-sections, one stacked upon another. And examples of this would be where there's research being done on 3D printing of organs, which will be quite a significant innovation. So no one has to be on a waiting list anymore. We have models being built out of 3D. We have parts being built out of 3D. Lots of innovative and fun things being built out of 3D printers. And there's IoT, which is Internet of Things. It basically relates to sensors on devices and things that are everywhere. So we have a host of devices with sensors on them, and these sensors measure properties of things and then stream those data over internet or 5G to fuel ML models and AI applications. These could include the AR, VR to inform actions. It could be robotics, autonomous vehicles, and examples could be applied to wearables, right? Again, health devices, Fitbit, for example. Your Fitbit collects information and streams that to your phone. You have connected cars, you have connected products. Your fridge maybe talks to your phone and sends you an email if you're out of something. We have precision farming, right? These are really great impacts in terms of how it's going to affect our life, or is actually currently affecting our lives.
And we got a note again from Hassan. I would really focus on 6G instead of 5G. It yields a data rate of 11 gigabits per second. 6G will be 100 times faster than 5G. So yeah, we're blown by what I'm on right now here in the house. So that's kind of amazing. And I was going to make another note. We did have, and I'm blanking on his name at the moment, but we had a gentleman. He's an assistant professor at the Toyota Technology Institute. He came to us with a presentation on the MIT DARPA Urban Challenge car. The car that they set up that had to navigate from point to point autonomously. And that presentation was really interesting and really engaging. A lot of people had questions. I hope that video is still up and available on the UChicago site, and I'll get it to YouTube. But that was really interesting, what you can do with autonomous vehicles. So
yeah. And now that you bring up 6G, I feel like I must bring up quantum computing. And that's going to blow all of our current communication protocol in terms of the way we communicate and compute. Is going to change. It's going to be radical. It's going to be crazy. I've seen some research that's currently being done for quantum networks at the Department of Energy, and it's just mind blowing. It really is.
All right, I'm gonna step in and just through the chat. Would quantum computing be an interesting topic for this group, especially if we put it in terms of AI and analytics, or just quantum computing in general? If you want to toss in a yes or no, or kind of a note in the chat, that would be great. And while that's coming in, Meki, I'll let you go ahead.
Right. All right. So this is a useful, very interesting website by PricewaterhouseCoopers. They have built this tool where you can actually, it's interactable, and you can interact with it to sort of see the impact of AI by different industries. So if you click on a particular industry, you can see the numbers change. I have the link right there, so you can actually, once the presentation is up, you can actually follow that and play around with it. It's very interesting. So it's not just in terms of what the use cases are, it actually sort of quantifies in terms of the change and has some sort of category scoring on the impact on a particular industry for these main things. Now, we've covered quite a bit of survey in terms of the different ways that we can use AI, both in our personal lives as well as in an organization or business enterprise. What do we need to know to actually take advantage of it? What are actionable steps that we can do? So let's start by talking about the challenges that are faced by enterprises in driving AI value, right? So we see that there are three main challenges that are faced. So we have marketing hyperbole, right? That's increasing confusion around artificial intelligence. Like Roger said, right? You have a lot of executives that go, let's throw AI at that. Let's do AI without any context of what the problem is, what the expectation solution is, and what the impact is going to have. Because of this wide use without construct, people struggle or businesses struggle to put a realistic value on the important source of innovation that will create that differentiation for them, right? You also have a second challenge is that the business leadership tends to overestimate, right, the impact of AI. They feel that AI is the solve all, be all of everything. So if you do AI, everything is going to be fantastic. And because they think of that as they overestimate the impact, they underestimate its complexity. They don't understand that it requires a lot of data and analytic managers to actually manage their expectations. The risk or the project will get very costly and certainly fail. The third challenge that organizations tend to face is integration, right? So usually there are already a host of technologies that are being used. So you want to make sure that when you're developing an AI or harnessing an AI technology, it actually integrates into the workflow or the other technologies. Otherwise, again, it's not going to get critical. It's not going to reach critical mass of engagement, people using it, and it's going to be a waste. And also, you have to think about security and privacy issues. That's a sort of a whole different presentation, I feel, for another day in terms of the impact of AI on security and privacy. But that's something that our organization leaders actually think about and explore about if it makes sense to actually bring it in. And without thinking through that consistently before they actually start, once they build the solution and then they come across these roadblocks, well, we have this mandate in terms of privacy or security that the solution that we just spent 3-6 months building and several hundreds of thousands of dollars basically breaks. And so we're going to put it in a freezer. So beyond those challenges, what are the barriers to actually successfully implement an AI within an organization? This I got from Gartner. And you can see in this list, in this chart here, that the higher barriers are ranked, right, by the sum of top three and the first choice based on organization. And the top, like we mentioned, in terms of the challenge, gels with it because it's the security and privacy concerns. That's the most critical barrier to organizations actually implementing AI. The second is the complexity of the AI solution, right? People overestimate the impact of AI and underestimates its complexity. So that's another critical barrier in terms of implementation and deployment successfully within a business organization. I'll leave this up for a little bit before I move on so we can take a better view. All right, moving on to the next slide. So how do we overcome all these barriers in terms of implementing successfully AI within an organization? This suggestion I got from Gartner. It's a very nice chart. I wrote out mine, but I saw this, I'm like, it's much better, prettier than mine, and it's very clear. So the right way to go about it is to outline in very 5 practical steps, right? We want to define use cases. As a business, you want to create a portfolio of use cases in terms of how you can use AI within your organizations. We went through quite a few survey. We went through the survey of the myriads of ways that AI can be used. But you have to look at your organization, the sort of operations, the way you use data, the way data is collected, what your initiatives and strategies and drivers are, your mandates are, and see if you can actually leverage AI and write down. Its use case could be simple as writing it down on a paper, not actually spending lots of resource time to build stuff. So write out the use cases. And then from that, you want to range and see, based on these use cases that you have identified, what is the quickest time to value? Which one of these do you want to start? So think of it as the lower hanging fruit that you get immediate impact from. What are the most valuable cases to begin with? And then you want to move on to skills. Now you've done the legwork in terms of identifying the use cases and which one or couple or several that you want to start with. Do you have the right skill set necessarily to do the implementation? Do you need to get outside contractor help? Do you need to get a ready-to-use AI system that you can plug and play with it that integrates nicely within your own technology? What about the data? Do you have the data to address those selected use cases that you align? If you don't, maybe then it's time to actually start collecting the data. What about the technology? Given the problem, the skills, and the data, what are the techniques? Do you have the technology to support the AI system if it's actually implemented? Now, if you have those 4 steps all taken care of and gone through, then the next step is to think at an organizational level where you're thinking, let's do a proof of concept. And after you've done a few proof of concepts, then the next point is, where should the expertise reside within your organization? Do you want it within your organization? Is it necessary to build a team within your organization? Or perhaps just have it, and for each organization, it's going to be different. There are some where it makes sense to actually build out a team, and there are certain organizations where it makes sense to actually have an external consult. Finally, right, as business folks, you probably know this, you all have to tie everything you do to the business value. And I say measure, measure, measure. What gets measured gets managed. So you have to measure, you have to come up with metrics that are pertinent to what the key values are. So it's not enough to say that we're going to save time. You have to show that we're going to save time in terms of operational costs, which means that you want to say, how much time are we spending on this particular task right now? You want to develop the performance metrics, keeping in mind that less is more. Limit the number of metrics to say 5 or 9 at a single managerial level, right? You want to use industry standard performance metrics when possible, so that comparisons with other similar organizations are possible. So you can say this is at the level, this is a level that our organization is currently performing, and compare with someone that's at a higher or further maturity in terms of the AI, and see how far back you are and where you need to work towards. You want to avoid gaps and overlaps in metrics that have been selected. You want to use a limited number of metrics that provide a 360-degree view of the activities being measured. All right. So for example, sort of the metrics that you might want to think of as resource hours, right? What about customer satisfaction ratings? Some sort of engagement metrics, actual cost in dollars in terms of spend, time to close, right? All these are simple examples of the sort of metrics that you can use to gauge the impact of AI to the business value at that managerial business operational level from before and after, as well as to other peer organizations.
Good. I'm going to call out there are some times where there's challenges. And you run into this. A good example is predictive maintenance. I love having conversations with people about it because it will predict that something's going to go wrong and it will pull something out to get it fixed. But the big argument is, well, how do I know it was going to break because you didn't let it break? And so how do you measure the value of something like that? So there are some things that AI does that are hard to measure.
I get your point, but as a mathematician, I would argue that you can measure anything. I would throw that back at you because it's not going to be exact or very straightforward relation like the predictive maintenance example you just laid out. But the way that one can probably overcome that would be say, for this particular period over the past, before we actually implemented the solutions, I would look at the time that was wasted overall when the machine was not active or the downtime. And you consider when you pull the machine to do the preventative maintenance on, that is still downtime. How does the downtime compare to the before and after? And that would still be a good metrics in terms of how effective that AI solution is working.
Yep. So that you can look at that. The other one, I'm digging through this book. I've started it multiple times, and I'm finally reading it all the way through. Weapons of Math Destruction, MATH. Destruction. So one of the things to think about is, measure. You've got to be very careful about picking what you're measuring because you can, really drive things in a wrong way if your models and your measures don't make sense. And examples I've taken, they were measuring teacher performance and firing teachers based on what was coming out of those models, and they were pretty much hidden models. They were just scoring the teachers based on these AI algorithms, and they were wrong. They proved, the best example I had is one teacher who was considered really good scored a 6 out of 100 one year, and the next year he scored a 96 out of 100, and he didn't do anything different. So whatever the model was doing inside was hiding too much of what was going on. So yeah, I think it's really good to say that, but sometimes it's not as easy to figure it out. If that makes sense.
That's absolutely good. So I was listening to a podcast recently as well. I forget the names. This is back early, I want to say in the 80s, back in Silicon Valley, where they're coding for a large company, and they're grading the developers based on the number of lines of code. And that is not the right way. And so there are people that will write 6 lines of code, but be able to basically build a whole solution, right? A whole application. Whereas the others that will write 50,000 lines of code, and that will actually break and have lots of issues with it. So choosing the right metrics is absolutely critical, yes.
Yeah. And I know another example that was very similar to the coding was idea generation. And a company came up with this really cool idea. Well, we'll find text that gets copied and pasted and sent around in these messages. And we'll look at who are the people that generate these pieces of text and who are the connectors who send it out to everybody. And very quickly they realized, number one, jokes get sent around a whole lot more than actual ideas do. So they took those out. But even then, they started to realize that it's really hard to identify an idea and to say that it's only relegated to emails. And they were, again, when we had a downturn a while ago, they were firing people based on that model that said, here are the idea generators, here are the idea connectors. If you're not one of those, we're going to get rid of you. And so, again, the measures were really not helpful because the models just really didn't work the way you'd expect, or the measures of those models weren't working that well. So it's interesting stuff.
There is a great book, How to Measure Anything. I would recommend anyone that's interested. There are several iterations of that now, but it's a really good read.
Okay.
So I think that's it, folks. Any questions, thoughts, comments?
Okay, I'm gonna, it's kind of related to this weapons of math destruction, but more of a general comment. I didn't see it, and I know this is a big topic, but ethics in AI. Do you have opening up big can of worms? Do you have any thoughts on ethics within AI?
I do. So many, so many thoughts. So, and they're different, so many different ways you can hack the issues that, or the probable issues that AI would have, the impact that it has in life. So you give the example of how teachers were being graded by this black box AI solution. The same concept relates to credit, right? Or judicial systems that basically sentence criminals. No one knows how this algorithm works because, of course, it's proprietary knowledge, but we're expected that it actually determines the livelihood and it has great impact on our everyday life. I am of the very strong opinion that any AI solution that has that impact on the public at large needs to be open and transparent in terms of how it works. As a matter of fact, I would go so far as to say that anyone really working on AI solutions should get certified. There should be some sort of a framework where you're trained in be able to recognize potential biases and other ethical things that are challenges before you actually design an AI algorithm.
Yeah, I would agree on that. That is a challenge, and it is important. In the class I teach, I talk to the students about the fact that most senior executives don't have a very strong background in statistics, let alone AI, and understanding how that works. And so if they, and they trust their gut a lot. They've made a lot of decisions up to this point in time by looking at the data and saying, we're going to go that way, or we're going to go that way. It's not based on a lot of data up to this point. And the successful ones were the ones that had a gut that helped them go the right way. But if you ask a data scientist to explain, these like neural nets, it's like, well, we've got all this data, we set aside some testing data, and we train the model, and then we test it, and it's there. And the executive goes, oh okay, but how does it work? And it's like, well, you've got this data, and you set aside the testing data, you got the train, and it's like, no, how, what makes it tick? So like you're saying, it's like, how do I make it transparent? How do I show what's going on? And there was an old example. Somebody proved that it didn't exist, but I loved it, and I'll use it here. An example is an AI algorithm that was used to help identify. It was used by a government organization to identify where tanks were in fields. And it was used because, again, tons of pictures over time, and they wanted to be able to find where they are as quickly as they could. They had all this data with pictures of fields with tanks, pictures of fields without tanks. They built the models, they tested it. It was all good. Turned it on, and it failed miserably. It took a while to figure it out, but they found out that in all of the data, the pictures of fields with tanks were on sunny days, and the pictures without tanks were on cloudy days. So they had built this really sophisticated AI algorithm to identify sunny and cloudy days, and it didn't care about the tanks.
I'll do you one better. More recently, I want to say a couple of days, there's an article written about this AI solution that was trained on lots of data, and it basically was put to identify Apple products. And all you really need to do is type the Apple symbol on the paper and paste it to any item, and it would identify that item as an Apple product.
There we go. Okay, we've got some stuff coming in. Let's see, Christian Cunningham. I've been told one of the biggest challenges implementing AI machine learning use cases is taking unstructured data and making it usable or compatible when taken from various sources. Any resources to better understand this? So it sounds like dealing with unstructured data.
So Dylan, I'm glad you bring that up. Dealing with unstructured data certainly adds a level of complexity. But if you would take a step back and imagine this for a moment, 90% of the data that we produce every day is unstructured, right? It's mostly textual with some numbers, maybe log days, maybe imagery, maybe video, sounds, right? Very few, very limited amount of data that we produce is structured. So it's something that we actually have to rise up to. There's no ifs and way about it. And there are lots of inroads in terms of the sophistication of the solutions that handle unstructured data. But I would raise you one much more higher. So the issue is not necessarily leveraging unstructured data, but leveraging variety of unstructured data and bring it all together in a way that it makes contextual sense. So not just the text, take the text, put it with the image, with the video, with the audio, and get insights that basically bring all those things into a convergence. That's what's very complex.
Yeah, an example, I did some work around healthcare and talking about that exactly. I've got radiographs, I've got doctor notes, I've got nurses' notes, I've got pharmacy drugs being delivered. Some of those are in handwritten form. Some are digital, some are whatever. And pulling those all together and coming up with an answer of some type is very difficult. So very hard to do. Let's see, I've got another one, but detecting bias in models is just as relevant in traditional models as it is with AI and ML. And I will agree with that. And the only thing I'll point out is in those other more traditional models, there tends to be some more visibility to what's going on. AI and ML tend to be much more black box. So it's harder to find those biases, are there to begin with. But yeah, the example weapons of math destruction uses is the college rankings. It's a weapon of math destruction. It's not an AI or ML kind of thing. It's literally just data that they've organized in a certain way, and it's literally what measures they picked to rank the schools is not good. And it's caused huge problems with how schools think about what they do. They don't think about offering what makes sense to students at a good price. They think about what can I do to up my ranking in that list, because that's how I get more students to apply to this school. So yeah, I agree that any model can be biased and need to be careful about it. And then, I'm sorry, Meki, did you have something you were going to say on that?
I did. It's more of every model can be biased, and classical modeling is not as bad because there's that transparency. I can see actually how we came to that conclusion, or whatever the end result was. Is much more hidden, like you said, with machine learning and or AI. I'll take you one further. So we haven't talked about this, but we mentioned quantum computing a bit. And one of the great advantages of quantum computing is going to speed up computation quite a bit. It's a whole different way of thinking about the way particles work, because it's based from quantum mechanics, right? Which is looking at particles at a subatomic level that the physics of them is much more different. Now, when that is applied to machine learning or to AI solutions, it's going to speed that up significantly. And the impact of that are going to be much more prevalent. So there is I was in a panel the other day talking about this, and that's why it came to the fore, because the impact of quantum computing on AI, as we know it, is going to basically enhance those biases that already exist.
Okay, something a little different, but a side note from Hassan, I would highly recommend looking at something called NFT, non-fungible token, cryptographic assets on blockchain, a special type of cryptographic token which represents something unique. This is very hot right now. And even Jack Dorsey is endorsing it. I'm not quite sure how it fits in, but now we're at least thinking about non-fungible tokens. Did you have something you wanted to say on that, Hassan? I don't know if he's there. All right, well, I'll go on to the next one. we can eliminate variable inputs that are forbidden by compliance or legal, and we can take in the same tact in building ML models. Besides this, what other technique do you suggest we can detect or mitigate biases in ML algos? So yes, you can make sure you don't put in any data that is restricted. For like lending algorithms, there's certain things you can't use, but there's a lot of stuff that ends up being correlated to those kinds of things. So for example, race is one of those things you're not supposed to use, but people found out pretty quickly that if you use zip codes in the model, it correlates very closely to race. Not intentionally, but it does. So there's those correlated variables that you also have to be careful of in putting those together. So we can see that. So there's more stuff coming in. Visible, I can exclude those. Okay, eliminating variables from the bias is extremely, eliminating, okay. Is causality also a big challenge when business uses AI ML to make decisions? Is that, I'll read that again. Is causality also a big challenge when business uses AI ML to make decisions?
I guess my question back to you is, can you clarify what you mean by causality there?
And this is from Li Lu.
Yeah, hi. My question is, is causal inference methods are also used a lot by the data scientists and AI technologists in the field? Because when we want to make decisions, we also need to make sure something is caused by another, not just look at the prediction.
Right. So if I understand you correctly, what you're asking if there's causality, if causality is an issue that people, data scientists or business people that leverage data solutions or AI solutions worry about. Is that correct?
Yeah.
Okay. So causality, when you think about causality, like with any model, you want to ensure that your variables, so let's take it back, right? Regular regression. What's the one thing we're doing when we're doing regression? We want to make sure that the variables that we're using in that model are independent, right? And so like Roger's mentioned about correlation, right? So there's a correlation not necessarily without causation, but if there is a causation, there is going to be correlation. And so that's something that can be identified preemptively while you're building model. It should be, it certainly should be part of that step.
Mm-hmm.
So it's not something that's worried about. If you find a variable that predicts another, that's causality without any independence, that's fantastic. That's what you want, right?
Yeah.
That's basically like a key feature in terms of letting you know what's going to happen.
Sure. Yeah, because I think in academia, there are growing number of research in causal machine learning and interpreting causal inference and AI. So I'm just curious whether these kind of new techniques are also used in the industry.
Not yet. So you have to understand that the industry is usually about 10 years to 20 years behind.
Mm-hmm.
Yes. So think of quantum computing that was discovered back in the 80s, and it's not in action yet, right? Now there's a lot more research being done focused on it, and hopefully in the next 10 years, not everyone, but most people will be able to use some sort of quantum computing in some intractable problem to solve some intractable problem or big data problem. Mm-hmm. But usually the industry is lagging always 10, 20 years behind academia.
Yeah, got it.
Okay.
Thank you.
All right, Anand asks, have you seen regulators giving a go-ahead on AI-based predictive models in banking? And yes, I think Joe DeCosmo presented at this group a while ago, and their fintech, Joe works at Innova, and they have fintech models that they use, but they've got to prove that they're not biased. That's one of the things the regulators want to see before they let them use it. And again, because it's kind of black box, they've got to do a lot of work to show that there's nothing weird going on. So it's a challenge. And then Mosh said data scientists should not be the ones guiding ethics, just like Roman Weil used to say auditors should not be charged with uncovering financial fraud. And in some ways I agree with that, but I think data scientists have to be ethical, be careful not to get the model started down the wrong path. But yes, somebody else has to be looking over their shoulders so that they don't make mistakes. An example of that is the Target story. I think where the father finds out the daughter is pregnant because Target sends an ad flyer to the daughter about basically baby stuff. And Target had figured out that this daughter was pregnant based on the kinds of things she was buying. And the father didn't like the fact he found out that she was pregnant from Target. Was that wrong of the data scientist? Was it not ethical? I don't know. Probably not smart, but kind of gray area. Somebody should have been looking. So.
Well, I wouldn't put the responsibility on the data scientists. I think their role in terms of their decision-making capabilities is limited to their model, right? This is more a leadership sort of decision. So I think we talked about this. So it's not, I don't think the decision in terms of what's ethical or not, or what's right or wrong should be placed solely on the data scientists, but they absolutely need to be critical that they are part of that solution, which means that they need to get some sort of certification or training that they maintain regularly and update as they work in that field. The leaders, whoever the managers is in terms of that maintains that solution, actually needs that sort of certification as well.
Yeah. And then William Hahn asked, what did regulators mean by bias? And there are things in lending that you can't have built into your model, and that so ethnic background is one of those. You can't judge lending based on that. It's just that's illegal. It's a law, and so he's got to prove that there isn't any bias in the model based on that ethnic background. So those are the kinds of things. Tell you what, let's. I know we're kind of at the point. I'd like to do the breakout rooms. And what I'm going to do is I set up 2 rooms, Meki AI and Rebecca Data Storytelling. I'll open the rooms up. If you look, you should have an option to go into breakout rooms, and you should be able to select the room you want to go into. And you can talk with Meki or Rebecca, or stay in the main room here and you can talk to me. We'll get kind of 3 different conversations going. So here I go, I'm opening the rooms up. If somebody's having problems getting into one of the rooms, let me know and I can assign you directly. I can put you in, I have that option. So let me check. Meki, can you get into your room?
Do I need to stop sharing?
Yeah, that would be good.
Okay.
And then
I don't see, how do I get into my, breakout rooms. The rooms are numbered, I think. Oh, I see, I can get in, perfect.
Okay, and Rebecca?
Yeah, I just saw it, yeah. Should be able to get in.
I'll let you guys get in there and then hopefully people are starting to head in there and we'll see how it goes.
Actually,